So this is your colab tool. So that is the product from the Google research. It is allow anybody to write and execute arbitrary Python code through this browser. Okay. So here we are going to see about how to implement a BFS algorithm in Python. So this is your Jupyter notebook to run the Python code through the online. Okay. Already we saw about how to implement a BFS algorithm. Here we are going to implement that algorithm in Python. Okay. So this is your algorithm. First we have to declare a queue and insert the starting vertex. Next we have to initialize the visited array and mark the starting vertex as visited. Next follow the below process till the queue becomes empty. So that is nothing but we have to check whether the queue becomes empty or not. If the queue becomes empty, the process will be terminated. If the queue is not become an empty, we have to do three things. One is first we have to remove the first vertex of the queue. Next, we have to mark the vertex as visited or not. Next, we have to insert all unvisited neighbor of that vertex into the queue. So this is your sample graph 5, 3, 7, 2, 4, 8. So 5 is the root node, 5 has a 2 child, 3 and 7. Then 3 has a 2 child, 2 and 4. Then 7 have the child 8. So 2 and 8 doesn't have any child. Okay. So already I said that we can implement the data structure in Python by using the dictionary and list. Okay. So here I created a graph as a dictionary. So already we know what is meant by dictionary. The dictionary is nothing but a dictionary can have a key pair of values. That is here in the sample 5 is a key value, then 3, 7 is a key pair of values. Okay. So graph is a dictionary name. Within the set bracket, we have to declare all the nodes and then neighboring nodes. Okay. So 5 has a 3, 7 is a child node. 3 has a 2 child, 2 and 4. 7 has a one child, 8. And then 2 doesn't have any child, so the list will be empty. 4 have a child, 8. And then 8 doesn't have any child. So this is your dictionary. Now we are using two lists. One is visited, another one is queue. So first we have to initialize two lists become an empty. Okay. So next we have to define the function BFS. It's have a parameter visited, graph and then node. So visited is an one list, graph is a dictionary, and then node is which node is going to be a first node. Okay. So that is node. Next, we should have to check which node is here visited first, and it will be appended in your visited list. So that is visited dot append node. Next, after appending the node, it will be in visited. We should have to append in queue also. So after the node marked as a visitor, it will be popped from the queue. It's another one thing. Next, we have to check whether the queue become empty or not. If the queue become an empty, the process will be stopped. If the queue value is true, so we have to do some three things. One is first we have to remove the first vertex of the queue. Next, we have to mark that vertex as visited. Next, we have to insert all the unvisited neighbor of that vertex. So suppose we mark first node as 5. So we have to check whether the node 5 has neighboring node or not. If the 5 has a neighboring node 3 and 7, it will be appended in the queue. No. Now we are checking whether the queue becomes empty or not. So queue is not an empty. So queue have the value 3 and 7. So now we have to pop the queue value. So what is the queue value? 5, 3, 7. So 5 will be popped from the queue. It will be stored in the value m. Next we are printing the value m. Next we are checking the graph m, that is graph of 5. So node, what is the node m? What is the m value? M value is 5. So we are checking graph of 5. So graph of 5 have the child node, that is neighboring node 3 and 7. So the neighboring node is 3, 7. So if the neighbor not in visited, we are checking visited list. So it is whether visited or not. Okay. So neighboring node is not visited. So it will be appended in your visited. So visited list. So we are appending in visited list also. So now what is the value of visited list? 5, 3, 7. And then 5 will be popped from the queue. Next, the queue dot append neighbor. So what is queue dot append neighbor? So already 5 will be popped from the queue. Next, we are appending 3 and 7 into the queue. So again, it will be continued till the queue become an empty. So what is the next process? It will be an 3 will be a next visiting node. It will be checked whether the 3 has a neighboring node or not. If the neighboring nodes have, it will be added in the visited list and also in the queue. Then next the front of the queue will be popped. That next value 7 will be come to the front. And again we are checking if the 7 have any neighboring node or not. If the neighboring nodes have, it will be added in the visited list and then queue also. Next we are popping 7 from the queue. And the next process will be we are checking whether 2 has any neighboring node or not. So 2 doesn't have any neighboring node. It will be popped from the queue. Next the neighboring node is next node is 4. Then 4 has any neighboring node or not. So 4 has a neighboring node 8. So it will be added in visited and then queue list. And then next 4 will be popped from the queue. And then next we are queue pointer will be 0.8. So 8 has any neighboring node or not. The 8 doesn't have any neighboring node. The list is empty. So the 8 will be popped from the queue and then inserted in visited node. So now the queue will be empty. So now again checking the while queue. So the queue is an empty. So the process of these things will be terminated. Okay, the process of these things. So the process of these lines will be terminated. So it won't execute the code again because the queue value was false. Okay, so next we can see the output 5, 3, 7, 2, 4, 8. So first we visited 5. So 5 have the neighboring node 3 and 7. And then next we are checking 3 has any neighboring node or not. It will be abandoned the queue. So next after that 7 will be print. After that 2 will be print and then 4 and then 8. So that is birth first search is nothing but level by level the value will be visited. Okay, that value or node can be visited. So now we can execute the code by clicking this run cell. Okay, so once we click the run cell, it will be executed. If the code doesn't have any error, it will be marked as a green tick mark and then we can get the output. So this is a simple implementations of VFS algorithm by using Python in Colab tool. Thank you.